My name is Mörth, and today I'm presenting you ScrollyVis. ScrollyVis has been implemented while I was at the Vis group at the University of Bergen, and currently I'm affiliated with the Harvard University and the Harvard Medical School. Storytelling on the web comes in various shapes and forms, like tweets, blog posts, or web pages. And nowadays, Scrollytelling has been widely adopted during the pandemic. And what you can see here is an article where you see geospatial information appearing on the fly on a map while you can read text accompanying it. Furthermore, InfoVis has also been shown to be effective when it's animated, and you can follow along different lines of interest here with these bar plots and these pie charts, and they then furthermore explain statistical features of the data. Furthermore, we can also use Scrollytelling to tell stories about, for example, new products, as Apple is showing here, and these can be very extensive and very complicated. In general, Scrollytelling web pages are quite complicated to create, but they can be a very effective manner to present, for example, also scientific data. That's where ScrollyVis comes in. Shortly, Scrollytelling, the definition, it's from Jan Schwochow. New content appears or changes through transitions as a user scrolls down or up the web page. So we see it's only a one-dimensional interaction with the user, which is the scrolling, and it's reversible and it should not be hacked. So it's always a fluid transition. What have others done in that space? So we can see here, for example, a company where Scrollytelling has been used to, for example, change pictures on the fly. For example, Webflow has used similar transitions, but they also use geometrical shapes that change while you scroll, and Wix has done a similar matter here. But we see that most of the very easy to create web pages, they only use images or videos, but they rarely use very complicated media, like for example volume visualizations, also like 3D objects, as we've seen in the example by Apple. So that's where we come in. So you see here two stories that we created with our web-based editor, and they both use very complicated media. On the left, a surface representation on a hip bone, and on the right we see the skull of a bear with actual direct volume rendering and ISO surface rendering in this case. So what does the ScrollyVis system looks like? The first step is the story editing, and we use a node link-based approach which we combine with previews, and in the end it looks like a storyboard. The story editing is conducted by the author, and what comes out of the story editing is an XML format which describes the whole story and the media you use within the story. In the middle we have the story compilation, which happens completely in our system in ScrollyVis, and the XML and the media formats are transformed to the CSS, HTML, and JavaScript. And in the end, we export a fully functional website which is ready to deploy, and you can view it in any standard web browser, and that goes to the viewer. So how does the system look like? The story editing happens completely in our ScrollyVis editor, which is web-based. So you can just open up a web page, and now we can tell, for example, a story about a bird. And what you can see here is that we use a direct volume rendering engine, and the data is actually a CT scan of a bird's skull. And I have this preview window here, so I can go to the exact spot I want to show from this volume. I can change it also to like ISO rendering, and so we see the beak nicely. Then I can add some text on top of it and tell the viewer that this is a bird's skull. And now the very interesting part comes in. If you want to do now a transition to a different part of the bird skull, you can just define that you, for example, want to zoom on the beak now. And we, in the ScrollyVis system, will calculate the transition automatically, and the viewer sees this transition just by scrolling. And now you can, for example, add another text on top of it. In the end, you would just press the export button, and what comes out is a ready-to-deploy website. And it looks like this. So you see it starts out with the name Bird Story by us, and when I scroll down I zoom in to this bird skull, I have a text accompanying it, and then when I scroll further I zoom into the beak, and all these transitions are calculated automatically. And they are also reversible, so you can always go back and forth and check again what you've seen before. But we don't stop there. we also have dynamic narratives. What does it mean? A dynamic narrative is defined by the viewer can change what they want to see next in the story. So I can ask the viewer actually a question, and depending on what they choose, the story can change. This can, for example, be used to show details on demand. So for example, you tell a story about MRI imaging and you want to ask the user, are you familiar with this technique? And if they're not, you can add some details on demand information. But what we use it here for is to determine in which direction you want to move. So for example, when you tell a story about a road trip through the US, I could ask you, when you start here in Boston, where I'm currently located, do you want to go to New York or to Salem, for example? So you can add this question node in the story editing, and then when it comes to this node within the story view in the web browser, you can choose New York or Salem, and depending on that, the story traverses in different directions. And the cool thing is you can always go back and choose a different option, and then you traverse a different aspect of the story. And it has been shown that this is effective for viewers to engage more in the story and have the feeling they are actually within the story. And this is also very common in like oral storytelling. So it often happens that you would ask the viewer, did you understand it, or do you need some more context to it? And if you say yes, you would tell some more information and then come back to the main branch of the story. And that's not possible with ScrollyVis. Furthermore, we allow various media types ranging from images, videos, audio files over like map-based visualizations. And then we also have these visualizations which are quite usable for scientific storytelling, for example, these volumetric representations, but also surface representations. So we have almost everything you need there to tell a compelling story. Furthermore, we allow for quite complex story flows. So what you can see here is a story flow where we first start out with a map view, then we show an image on top of that. So we go down first, then we go down again. So you see 1A, 1AA, and then we have a text on that image. And then afterwards we replace that image with another one. So we go to 1B, and then we traverse back up to the map and replace it with another map. So always when you go down within the story editing, you show something on top of the one we have before. And when you go to the right, the story flow traverses and it replaces what you've seen before. So what happens now in the end? You're finished with the story, you press either the copy or the export button. What does the copy button do? It copies your story editing so you can use it later as a template again to create, to add more to your story or to edit it again. But if you press the export button, the XML comes out and the accompanying media files you have, and they go into the story compilation. So we have a standardized format how to represent the story, which can also be used to create stories automatically. So you could have an engine, an AI or something similar along that lines that just creates this XML, and then it goes the rest through the same system. So it doesn't always have to be the story editor to use our editing software in creating a story. And in the end, the story content is presented in HTML and CSS, and the story transitions are presented in JavaScript. And all these together form the actual story. And you see here we have some packages that are loaded always, like the volume viewer, the video code, Sketchfab, and so on, meaning that these are the ones that make it possible to present all the different media formats. And then we have some content which is created on demand based on the actual story you created. And the story presentation can happen in every standard web browser, Chrome, Firefox, Edge, you name it, or even Safari also. And we use 3GS for the volume representation, Mapbox for map-based representations, and Sketchfab for the surface representations. And here are some examples of stories we created together with experts in the field. So this is, for example, a recreation of a story from The Economist, which is about an archaeological site. And they have laser scans or LiDAR scans of an archaeological site, which is hosted on Sketchfab, which we can just load in our editing software and then tell a story about the different complexes and the different features of this archaeological site. And it's very easy, you can create it within minutes. Another example is one about the hip bone, which we created together with anatomists. And this is to tell students about different parts of the hip bones, and you can even include a quiz there, so the students can go through the story and choose what they think that the different parts are, and they will get a feedback automatically to tell them if it's right or wrong, which is very engaging to learn different aspects about anatomy. So we have created 3 different stories together with experts to show the utility of our approach. And furthermore, we've also invited an expert in storytelling who has worked with Microsoft, NASA and Apple, and he told us that especially the nonlinear paths are very compelling and are normally not supported by comparable tools. Furthermore, the high quality of the presented stories and our editor impressed the expert, and in the end, the expert told us that it's very important for scientific communications and our editor could make a significant contribution in that field. We also evaluated our approach with 12 participants, ranging from undergraduates to PhD students, and we had them create 2 stories per participant, and we tracked the time it took them to create a well-defined story. Furthermore, we also tracked the success, if they were able to create the story we imagined, and then we asked them 21 questions about the editing and how well it went. So for the evaluation, we had 1 story, which was for them to get familiar with the editor. So we gave them the media and said they should tell we gave them a template and told them you should tell a story about this bird and here's the media you should use. And then the second story was a very well-defined one where we told them exactly what they should create so we can track the time and compare them to each other. So we got overall very good results and they were very happy with the editor, and many of them wanted to use it in the future. And for the second story, we tracked the time, and on average it took them 5 minutes to create this story about their last holiday. And for the system usability scale, we got a best imaginable or A+. For details about these results, you can read them up in the paper. Now, to reflect, scientific storytelling is very important and it's very time consuming, and the expertise is often lacking to create these. Working with different media is also very challenging, as we saw here. When you use surface representations or volume representations, it was very difficult to get these into the editor. And it's also dependent on hardware. So if you want to present these and then viewers view the story on a phone, it could be that it doesn't load, so you have to use alternatives like a video of the same, so it works for everyone. And dynamic narratives, meaning the viewer can change the path in the story, are engaging, but they're very difficult to produce, but we managed to do so in our software. So what are the next steps? We want to improve the website's performance, especially in online rendering, meaning the story that is exported has everything you need for 3D rendering, but often that doesn't work on mobile phones, for example. So we are thinking to maybe include online rendering steps so it works for every device. Furthermore, we want to provide story templates and guides so people have an easier time to create a story, for example, about their last paper. And this could even be something which runs automatically. We want to also include animated data visualizations because they are very important to tell compelling stories about your data, which is also often given in science communication. And we want to conduct more user studies, where one has already been conducted. It's called Is There a Tornado in Alex's Blood? And you can read in the paper about it. So to conclude, we present ScrollyVis, an interactive visual authoring of guided dynamic narratives for scientific scrollytelling. And dynamic narratives means the viewer chooses the path. We have various media types within our editing software. We can present 3D data, either surface or direct volume rendering, audio, video, images and maps, so it's very extensive. And we produce a ready-to-deploy website where the code is still editable. Thank you very much, and here's a link where you can actually try out the editor on your own, and please read the paper for further details. Thank you.